Right, question 4. A ball of mass 2 kg is moving with a velocity of 3 meters per second along a smooth horizontal tracks, collides with a stationary ball of mass 4 kg. If the balls are stuck together after the collision, calculate the common velocity after the collision, as well as the total kinetic energy before and after the collision, and state whether the collision is elastic or inelastic, hence explain why. Okay, so I've extracted the information and I've drawn the diagram to kind of give you a rough idea of how the ball is moving. So we have the first ball is moving at 3 meters per second. So it is moving towards a stationary ball. That's why I put u equal to 0, because it is not moving. So this ball is not moving. The only ball is moving is the first ball here. So it is going towards this second ball, and after the collision, which is here, they are moving with the same velocity. They are moving in a single velocity. So now we have to find what is this common velocity. So how do we do that? We know that the total, based on the principle of conservation of linear momentum, we know that the initial total momentum would be equal to the final total momentum. Okay, and how do we calculate this? We know that momentum is equal to mv. So m1 u1 plus m2 u2 equal to m1 v1 plus, sorry, it's okay. You need the general equation. This is the general equation. But in this situation, it has been stated that they are moving together. So we know that we only need to put 1v, which is there lah, v yang di situ. Okay? Okay. And then now we can just substitute je lah the values. Okay? So let's substitute this plus 4 u2 is 0 equal to 2 plus 4. V is what we are looking for, and then you'll then get the common velocity to be 1 meter per second. Okay, and then we have to find the total kinetic energy both before and after the collision. We know that kinetic energy can be calculated using the formula half mv square. Okay, always remember the square, because a lot of my past students forgot to write the square. They just remember to write the half, but they don't write the square. So salah lah jawapan. Okay, so now we can find the total kinetic energy initial, which is before the collision. So half m1 u1 square plus half m2 u2 square. This one is automatically 0 because the initial velocity is 0 lah. So half m1 is 2, u1 is 3. So 2, 2, 3. Dapatlah 3. Tengok saya pun lupa. So square. Okay, remember square. So 3 square is 9 joules. Energy should be in the unit joules. Okay. And then we have to find the after collision, which is the final kinetic energy. So half m1 u1 v1 lah, v1 vv. We are using v. So just now we have the common velocity, so we just use v lah. Okay, so this is half m1 is total. Nanti kamu bingung nih. So m1 plus m2, okay, v square. Okay, boleh je kamu tulis like this. Satu untuk the 2 kg, one is for the 4 kg, but that is tedious, so you just simplify it to be like this because we have one common velocity. Okay, so m1 is 2 plus 4v is 1, and then you'll get the after punya kinetic energy to be 3 joules, which is not the same. So when kinetic energy initial is not the same, it's not conserved, if the kinetic energy is not conserved, what does it mean? It means that the collision is inelastic. Collision is inelastic. Okay, why? Because the total kinetic energy is not conserved. Okay, so that is the reason why we call it inelastic collision. Right, so this is your question 4.